Plus, this podcast is going to be a two-parter, and both the parts deal with what's known as VSEPR theory. And usually we just call this VSEPR theory. And you might jot this down. It stands for valence shell electrons. So again, there's outermost electrons in the valence shell. So the main thing is just electron, but valence shell specifically. Electron pair. So when we've been drawing Lewis structures, know that there's pairs of electrons that represent bonds. So when we're talking about bonding, when you think electron, you should automatically think two dots. Okay, so if we have electron pairs that are around an atom, what are they going to do with each other? Because they're all negatives, they're going to repel each other. So VSEPR is valence shell electron pair repulsion. And the idea is that these electron pairs are going to repel each other, and because of that, they're going to want to be as far apart from each other as possible. And what you're going to see in our second part of this is that they arrange themselves in specific shapes that we can predict. Alright? So the way this is going to look is, I'm just going to put a random atom out here. Let's just call it A, because A is not on the periodic table. And let's say I had some dots here, and some dots here, and let's say I just had some other element. Darn, I picked B. It's not going to be boron, it's going to be B element. And it's kind of like this. And that is what it looked like. Or maybe we do two pairs of dots, because everybody wants 8. So something kind of like that, maybe dot, 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 dot. Alright, so here's hypothetical idea. So what valence shell electron pair repulsion is, it only deals with the central atom. So we are simply looking at our atom in the middle, and you're going to ask two questions about it. And these questions are right over here. I'm just going to label them 1 and 2. The first thing is, how many areas of electrons, or shared areas of electrons, are there around the central atom? And that's what I mean by shared clouds, right? We've kind of talked about electron clouds. So shared areas, shared clouds, but something kind of like that. So right now, if we kind of just draw our little, Venn diagrams, we have one area on the left, and we have one area on the right. So that's simply going to be 2 shared clouds. How many lone pairs do I have? And it's only around the central atom. And notice the central atom has no lone pairs. It has shared on both sides, but that is it. So this would be 0. And then finally, our total areas is simply going to be the sum of our shared and lone. So notice 2 plus 0 equals 2. And that is all we're really doing for now. Alright? Or actually, let's put the shape in. The shape of this is going to be linear. And you're going to kind of see what that looks like on part 2. Alright, so the next thing we do is, again, let's just say random atom A, and let's put some dots kind of like this, and we'll just do B and B again, and this is probably the last time I really give an example. Well, I know, we might do an example another time. Alright, but we have something kind of like this. So if we Venn diagram it up, B has 8, B has 8, A has 8, we have a single bond, we have a double bond, and we have a lone pair. Alright, so in this case, shared clouds again, and we're only talking about the central atom. So we have 2 shared clouds. We have one on the left, we have one on the right. They're a single bond and a double bond, but they're still shared in that side. How many lone pairs do we now have around our central atom? We have 1 lone pair. And notice that 2 plus 1 equals 3. Okay? And this is going to be known as bent. Alright, our next example, let's see, we're just going to do this, A, and we're going to have B, 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 and I'm not going to put dots everywhere, but let's just say we had something kind of like this, because I'm only really concerned about my central atom. So how many areas of electrons do I have around my central atom? I have 3. How many lone pairs do I have? I have 0. And notice 3 plus 0 equal 3 again. Alright? And the shape of this is going to be trigonal planar. Alright, trigonal planar, and we're going to leave it like that. Alright, notice 2's have one option. Notice if we have 3 clouds, we have 2 options. Alright, so 2's have 1, 3's have 2, and then down here, as we kind of look ahead, 4's actually have 3 different options. So if we do our first one, we're simply just going to have A with 4 things around it, B, 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 and 2 dots between. So 4 shared, 0 unshared equals 4. And there's 2 other ways this could fall out. We could have 3 and 1, or we could have 2 and 2. But each of these is going to add up to 4 every time. So if we have 4 shared and 0 alone, this shape is known as tetrahedral. If we have 2 and 2, we're just going to skip to this one. It's going to be bent. And then our last one is going to be trigonal, pyramidal. Alright, and that is part 1 of VSEPR.